Welcome back. Here are another set of problems on counting. So the first problem is, in a class of 100 students, 65% like apples, whereas 75% like grapes. So what percentage of students like both apples and grapes? And then the second one, in a survey about liking for colors, it was found that everyone who was surveyed had a liking for at least one of the three colors, namely red, green, and blue. Further, 30% liked red, 40% liked green, 50% liked blue. And further, it was found that 10% liked both red and green, 5% liked both green and blue, and 10% liked both red and blue. Find the percentage of surveyed people who liked all the colors. And question 3, if in a city, 60% of residents can speak German and 50% can speak French, what percent of residents can speak both languages if 20% residents cannot speak any of these languages? Now, all these three questions are testing on counting involving percent or percentages. So it is always easy to make our universal set to be 100%, to be 100 when values are expressed in terms of percent, to make our computations much easier. But even if we fix a different value from 100, we still, and interpret the question correctly, we still get the same answer. But for convenience, we pick 100 as our universal set. That is one. Two, in question 1 and question 3. So when you are told that if in a class of 100 students, 60% like apples, whereas 75% like grapes, so we'll have to determine the percent of students who like both apples and grapes. So silently within the question, it is assumed that of all these 100 students who were in survey or who were surveyed, if we were to draw a Venn diagram, then we expect that each and every student should be within the sets defining those who like apples and those who like grapes. Unlike in case 3, whereby then the information is very clearly given that 20% have no do not speak any of the two languages given in the question. So in 1, when you draw the Venn diagram or when you start to interpret the question, note that the 100 is the same as the cardinality of the union of the two sets involving apples and grapes. But in 3, it's very clear that outside the two sets, for those who speak German and those who speak French, you have 20%. So let's demonstrate clearly how we solve this. Solution. So we can let A to be the set of those who like apples, and then G, those who like grapes. So the cardinality of those who like apples from the equation is clear that 65% like apples. So cardinality of A is 65% of the total number, which is 100. So the answer is 65. And cardinality of G from the equation is very clear. It is 75% of the total 100. So 75% times 100, we get 75. And because there's no information that none of the students who are in the survey have no liking of the two fruits, then the 100 is what defines the cardinality of the A union G. And for us to find those who have are liking for both apples and grapes is the same as finding the cardinality of A intersect G. So this is the question. From the inclusion-exclusion principle, cardinality of A union G is cardinality of A plus cardinality of G minus cardinality of A intersect G. So which will be given by, this is 100, cardinality of A is 65, G is 75, and then this is what you're solving for. So 100, when we add 65 to 75, we get 140. So which should be very clear that the cardinality of the intersection is 140 minus 100, which is 40. So in terms of percent, this means that 40 over the total 100 times 100%, which is equals to 40%, like both apple and grapes. So just application of the inclusion-exclusion principle. B, so we have three main sets, red, green, and blue. So let R be those who like red color, G, those who like green color, and B, those who like blue color. Now we can let the total number be 100 because things are given in percent. So which means cardinality of red or cardinality of R is 30 over 100 times 100, which is 30. Then those who like green are 40%. So 40% of 100 is 40. Those who love blue or like blue are 50%, so 50. Further, we have been told that 10% like red and green. So RG then, and then 5% liked green and blue. So GB 5, and then 10% liked both red and blue. So RB is 10. So the equation here was find the percentage of the surveyed people who liked all the three colors. So it's like we are looking for cardinality of R intersect G intersect B. So this is the equation. And because in the equation itself, we were told that of all those people who are surveyed, each one had a liking for at least one of the three colors. So it means that the union of all the three should give us the total 100. So R union G union B should be 100. Now from the inclusion-exclusion principle, R union G union B is cardinality of R plus cardinality of G plus cardinality of B minus cardinality of R intersect G, G intersect B, R intersect B plus R intersect G intersect B. This by definition the formula for describing the cardinality of union of three sets. So then we replace in the values. So we'll have 100 equals to 30 plus cardinality of G is 40. Cardinality of B is 50 minus cardinality of R intersect G is 10. GB is 5. RB is 10. Then plus cardinality of the intersection of the three. So which will be 100 equals to now 30 plus 40 plus 50 minus 10 minus 5 minus 10 is 95 plus R intersect G intersect B. So which means we'll have R intersect G intersect B will be 100 minus 95, which will give us 5. So in terms of percent, will be 5 over the total we picked was 100 times 100%, which will be 5%. Add a liking for all the three colors. So that's how we were to work out question 2. And lastly, question 3. If in a city 60% of residents can speak German and 50% can speak French, what percent of residents can speak both languages if 20% cannot speak any of these languages? So let's also pick our total number to be 100. So let total number be total resident number 100. So which means there's two main sets. So those who can speak German, 60%. So 60% of 100 is 60. And then those who can speak French, 50%. So French speakers, 50%. Now, if 20%, so non-German and French speakers will be 20% of the total, which is 20. So which means the union of G and F will be simply 100 minus 20, which is 80. So because if you were to draw a Venn diagram, so you'll have set G, and then you'll have set F. So if this is A, B, C, D, so those who can't speak any of the two languages will be outside the circles. So this value of D is what we have 20. And the union will be A plus B plus C, so which will give us 80, so that when we sum up, we get 100. So then by definition, G union F is cardinality of G plus cardinality of F minus cardinality of G intersect F. So G is 60, so this is 80 equals to 60 plus 50 minus G intersect F. So 80 equals to 110 minus G intersect F. When you make G intersect F the subject, you get 110 minus 80, which is 30. So in terms of percent, will be 30 over 100 times 100%, which is 30% residents can speak both German and French. So that's how we interpret that question. Thank you.